Alright, let's dive into GloVe. GloVe is fast, scalable, and it works well on smaller data sets. So how do we derive our cost function that we need to minimize? Well, remember in Word2Vec, we were trying to find VC and VW. Context, embedding, here is the center word, embedding. And the formula had the dot product, and this was done in order to find similarity between these two vectors. Now here let's just set C to I and W to J, so that our vectors are VI and VJ. Here on this side we have our co-occurrence matrix, and I took a very simple corpus here, the cat. Diagonals are 0, and we know that here we have the global count of the co-occurrence of the and cat. Yeah? This matrix is symmetric. Yeah? Xij equals xji. So this one and this one are the same thing. So now what I want to try to predict is what is the likelihood, or what is the probability of getting the word cat given the word V. This is what I'm trying to calculate. Now we know that xij, the number that we have here, this number could be 250. We need to divide to the sum of all the counts in that row I. Yeah? So sum over I of xij. Alright? So if we calculate this is xij divided by xj. Alright? Because here I sum over all the i's, but I still have the j left. Alright? So, what we're going to do now is we're going to take the log of the probability of j given I, and we're going to set that to Vi transpose Vj. Yeah? So we're going to set the log of this thing equal to that. Yeah? Now that means that we have here the log of xij divided by xj equals to Vi transpose Vj. So that means that the log of xij minus the log of xj equals Vi transpose Vj. Yeah? Because the log of A divided by B is the log of A minus the log of B. Now, we can also change these guys here. Put J first and then I. Yeah? What's gonna change here? Well, not this one, because we know that there is symmetry. So this remains xij minus the log of xi in this case. So what I'm gonna do now is I'm gonna add these two up, and I'm gonna bring this side to this side. So I have 2 times Vi transpose Vj equal to 2 times the log of xij, right? Minus the log of xi minus the log of xj. And what I'm gonna do is I'm gonna divide by 2, so this is half. Yeah, and I will call this Bi, and I'll call this Bj. Alright, so we have then that Vi transpose Vj equals the log of xi minus bi minus bj. That means that the log of xij, this one here, is vi vj plus bi plus bj. Alright? So this is my true global count. And this is what I'm trying to predict. Try to predict. Yeah, these are my parameters theta. Alright? So it's quite obvious our cost function will be C of theta equals, and I'm gonna take this one, vi vj plus bi plus bj, and I'm gonna subtract this log of xij, because that is what I'm trying to predict, and that is a true value. So the difference is basically the error. And usually what we do is we take that between brackets, we square, we divide here, because when we take the derivative later, these two will come to the front, and we'll take the sum over I and j. And here I'm going to add another function, xij, and that function takes care of high frequency words. Yeah, this allows us to cap, for example, the count of high frequency words. So this is it. So basically our goal is to minimize over the parameters theta of that cost function. Yeah, and then we do gradient descent and so on. Yeah, we've done it numerous times before. I'm not going to go into the details. I just want you to see how we got to the cost function of GloVe, and it's basically by making a combination of these two. All right, that's it for word embeddings.